Alrighty, good morning. We are working on section 7.2 in your textbook, continuing with that. We're on worksheet 7-2A, okay, which are posted, blank copies are posted at the top of the Schoology page, okay, within the Unit 7 folder, okay. Today we're focusing on simplifying rational exponents. So we're kind of working with radicals and exponents in this unit. So what we're going to do is review real quick the exponent rules, okay, and then we're going to apply them, but they're going to be rational exponents, okay, and I'll explain what that means in just a moment. So here, if you remember, when you multiply, okay, you add your exponents. So this guy, the base doesn't change, so you never change the base, okay? So this is 3 plus 4, so it's a to the 7th, okay? Then here, if you have an exponent, okay, and a power, what you're really doing is a to the 5th multiplied by itself 3 times, okay? So what that means is we're actually going to multiply the exponent and the power. So this becomes a to the 15th, okay? Then this one, okay, basically what you're doing is you can multiply what's inside here, okay? So 2 times 5 is 10, and then x times y, because those are different variables, and then everything is raised to the 4th power. So that means we have 10 xy multiplied by itself 4 times. So if you remember, we could write that out. So that would be 10xy times 10xy times 10xy times 10xy. But a lot of you like to do the shortcut, which is 10 gets raised to the 4th power, x gets raised to the 4th power, and y gets raised to the 4th power. So basically, just like we did up here, right, that 3 got applied to everything inside here. Well, there was only one thing, right? So we multiplied it or raised it to the 3rd power. So now I'm just raising everything to the 4th power. So now 10 to the 4th is, right, 4 zeros, then x to the 4th, then y to the 4th. The big thing to remember is always raise that coefficient to the power as well, okay? Then with division, right, we're always going to do subtraction. So this is z to the 5 minus 2, which is z to the 3rd, okay? And then here, this one, you can see they have the same base. Notice all of these have the same bases, 1, 2, 4, and 5, okay? So we can do our properties of exponents. That's going to be important today. D, right, and D, these two I subtract. I always do the numerator minus the denominator, so then I get d to the negative 4th. Sorry, d, not a. So therefore, I have to rewrite this as 1 over d to the 4th. So if you remember, we have to drop that negative exponent to the denominator, okay? Another way to think about this is there's more d's on the bottom, right? So this is like bottom heavy, so when you subtract the two, the answer will always end up in the denominator because there's more d's there, okay? Now, we're gonna also use fractions with exponents. So we have to remember, when we're adding fractions, right, you just add the numerators. So denominators have to be the same. So denominators the same. Then you're gonna add the numerator. Okay, so 1 plus 5 is 6, right? So we're gonna have 6 over 2, which if I reduce, and you should always reduce, 6 divided by 2 is 3. So that will become a 3, okay? Now, if we're multiplying, right, we just multiply across. Too many C's. Cross, okay? So I'm gonna go 1 times 5 and then 2 times 2, right? So that gets me 5/4. And I can't reduce that, right, by any common factor for 5 and 4, so I'm good, all right? Then here, just remember, this is really 2 over 1. So then when we multiply across, it's 2 times 5 and 1 times 2. So then we get 10 over 2, which is 5, okay? So we're going to combine these ideas of simplifying fractions, but now if you look down here in our examples, they're actually going to be our exponents, okay? So properties of rational exponents, that just means fractional exponents. Okay, so we're dealing with fractional exponents. Now, I know we all love fractions, okay? Use your calculator, all right? But I'm going to simplify these, all right, in exponential form, okay? A and B are positive numbers, M and N are rational numbers. Just meaning here, like they're numbers that are nice to work with, okay? They're not irrational, all right? So this is just a review of the properties that we talked about. So when we multiply, we add. So here, if you look, the bases are the same. The base does not change. So you're just going to do 3 to the 1/2, right? Plus 3/2, right? So if you remember, okay, if you remember, that is, we're just going to add the numerators, right? So it's really 1 plus 3. So 1 plus 3 is going to be 3 to the 4 divided by 2. Now 4 divided by 2 is 2, so this is 3 squared. That's your answer, okay? So it should be in exponential form, okay? Then if I go to my next example, okay, I have 2, right? And then this is my exponent, this is my power. So I'm gonna keep the base the same, okay, so the bases don't change, and then I'm gonna do 3 over 2 times 2, right? So now, since it's multiplication, I'm gonna multiply across, so it's 2, and then 3 times 2 over 2 times 1. You don't have to show this, I'm just showing you what I'm doing. So then this becomes 2 to the 6 over 2, which 6 over 2 is 2 to the 3rd, okay? So my base is the same, right? I'm just multiplying my exponents because I have an exponent and a power. Now, this guy is a little bit different, okay? There's 2 different ways you could kind of write this one. You could write it as 9 to the 1/2 power times 4 to the 1/2 power. So see how I'm raising both of these? These are different bases, right? So I just raise them both to the 1/2 power. Or what you could write is you could multiply these two and write it as 36 to the 1/2 power, okay? Either one of those is fine, all right? Now, just so you know, we can simplify these, okay, or I should say evaluate these two numbers, right? So 3 squared would be 9, right? 2 to the 3rd would be 8. 36 to the 1/2, remember 1/2 power is the square root, so that would be 6, okay? So we can evaluate these. Right now, though, I'm just writing them in exponential form, all right? This guy, no negative exponents, okay? So here we're just gonna do 1 over 16 to the 1/2 power, okay? That's all you have to do, all right? Now, if I ask you to evaluate it, it would be 1 over, well, 16 to the 1/2 power is 1/4, okay? So that would be 1/4. But again, we're just writing in an exponential form. These are the same bases, so since I see division, that means I can subtract, so I'm gonna have 5. The base does not change. The bases do not cancel. You're just simplifying the exponents. So 3/2 minus 1/2, right? So subtraction is the same as addition. We did up here, so I'm just gonna subtract my numerators. So that's gonna give me 5 to the 2 over 2. The denominator does not change. So 2 over 2 is just 1. So this becomes 5, just to the first or 5, all right? This guy, right, if you look, all they did is, see this exponent of m? That just applies to both the numerator and the denominator. These are different bases, okay, within here. So I'm just gonna write it as 8 to the 1/3 power divided by 27 to the 1/3 power. That's all you can do, okay? Now, I'm just going to show you, remind you that if you evaluate this one, so if I ask you to evaluate it, 8 to the 1/3 is really the cube root. That's what we were doing in our last section. So this would actually simplify to the cube root of 8, right, or 8 to the 1/3. You can put that right in your calculator. All right, so if I did 8 to the 1/3 power, I would get 2. So that would be 2. And then 27 to the 1/3 power, okay, would be 3, okay? So that would evaluate as 2/3, just so you know. But I'm gonna have you write them in exponential form, okay? All right, so let's look at some examples, all right? So I'm gonna do the first row, then you guys can hit pause and try the next one, and then I'll go over those. All right, so here's what we're doing. Bases are the same, so I'm going to add my exponents. So 1/2 plus 3/2 gives me 2 to the, just add your numerators, 4/2. So 4 over 2 is 2, so this is 2 squared, okay? Now I ask you to simplify in exponential form and then evaluate, right? So this is my first answer, and then my evaluated form would be 4, okay? Because 2 squared is 4. So there's my 2 answers. Here, I see 4 to the 3/2 power squared, so I see a power, right, and an exponent, so I'm going to multiply these. The base stays the same, so 3/2 times 2. So I'm going to make that 2 over 1, and then I'm going to multiply across. So 3 times 2 is 6 over 2. So this becomes 4 to the 3rd, because 6 divided by 2 is 3. So that's my exponential form, and then my evaluated form is 4 to the 3rd is 64. So that's my answer there, okay? This, again, the bases are different, so you could write it either as 4 to the 1/2 times 9 to the 1/2, or you could write it as, multiply inside here, 36 to the 1/2. Now, these will evaluate exactly the same way, because if 1/2 power, remember, means a radical, right? So 1/2 means the square root. So when I take the square root of 4, that's 2. Square root of 9 is 3, and that gives me 6. Or if you look at this one, it's just the square root of 36, which is 6. So either way, they evaluate the same way. Okay. The next one, I have 5 to the 3/2 and 5 to the 1/2. So the bases are the same. So I'm going to subtract the exponents. So it's 5 to the, well, I subtract just the numerators, right? When I'm adding and subtracting, it's just the numerators that change, okay? And again, the bases are always the same, okay? So 3 minus 1 is 2 over 2. So this is 5 to the 1st, okay? This, and then there's nothing to evaluate because it's just 5. Okay, so that's my only answer there. 5 is the evaluated in exponential form. 27, right, is raised to the 1/3 as well as 8 to the 1/3. So that's your exponential form. There's nothing else you can do there. Then if you remember, 1/3 power is really the cube root, right? Because this is your power, right? This is 1, which really doesn't matter, okay? And then 3 is your index, so that's the cube root. So the cube root of 27 is 3. The cube root of 8 is 2. So that's your evaluated answer, okay? This one, no negative exponents. Okay, so what we're going to do is we're going to drop this to the denominator, right? Had it been in the denominator, move it to the numerator, okay? But right now I'm dropping it here. That's my simplified exponential form, okay? There's nothing else I can do there. So then I get 1 over the simplified. Well, remember, 1/2 power is square root, so this is 1/2. That's my answer there, okay? Now, if you look, the next set of examples are very similar, okay? So I'm gonna be asking you the same type of questions, all right? So you can hit pause, try these, okay, if you'd like. If not, I'm gonna go through a couple more examples here, all right? So notice bases are the same, okay? So if I'm doing bases are the same, this tells me that I'm gonna add my exponents. So 3 to the 1/2 plus 1/4. Now this one's a little tricky. Let's put a little star there. Because what's the problem? These are not the same denominators, right? So what you have to do is multiply this by 2/2 and make the denominators the same. You remember doing that in the past? So this becomes 3 to the 2/4, right? We make the denominator a little bit bigger, plus 1/4. So therefore, now that the the denominators are the same, my base stays the same, still 3. And I'm gonna add 2 plus 1, that gives me 3/4. Okay, so that one's a little tricky. Okay, I think there's one on the homework like that, so pay attention to that. This one, I see the parentheses. This is my exponent, that's my power, so I'm gonna multiply these. The 2 stays the same, so it's 5/4 times 4/1. Remember, that's really 4/1. So then this becomes 2 to the 20/4 when I multiply across. So then that's 2 to the 5th power, okay? Which 2 to the 5th power, that would give me 2 times 2 times 2, 32, right? If I multiply 2 by itself 5 times. This one, by the way, I did not evaluate. Forgot about that. I'm gonna put that in my calculator, because 3 raised to the 3/4 power is not gonna be very pretty. So that would be 2.3 about, okay, if I round the answer, all right? Because I know this is power over index, so what the calculator is doing there is it's using the power of 3 and then taking the 4th root, which I know is not going to be very pretty. So that's why we have a decimal, and that's okay. This one, different bases. So what I would do here is you can't multiply these two guys because they are different bases. So the only way to simplify this one is similar to what we did here. You're gonna do 5 to the 4th times 1/4. So everything gets raised to the 1/4 power, times 3, okay, to the 1/4 power, right? But there's 4 times that. So now if let me erase it so I have more room. So it's 4 times 1/4, okay. So again, these guys cannot be multiplied because they have different bases, okay? So I'm gonna leave that like that, but my other option is to raise both of them to the 1/4 power. So if I do that, well, 4 times 1/4, that's just 4/4, which is 1, right? And then 3, 4 times 1/4 is 4/4 if I multiply across. So this really just becomes 5 times 3, which is evaluated 15. So that's your answer there, okay? So I wanted you to basically kind of distribute, if you will, not technically distribution, but distribute that 1/4 to both those exponents, okay? Now, this guy, can we do anything with this? No, I'm emphasizing here you can't simplify because bases are different. So there's nothing to be done here. So just leave it like that. We can't add or subtract anything, right? I should say subtract because I see division. I can't do 1, right, minus 1/3. So I just leave it, all right? That one cannot be simplified. Okay, now this guy, you can raise both of those to the 1/4 power, okay? So this would be 128 to the 1/4, and then 8 to the 1/4, okay? That's my simplified exponential form, right? Then when I go to evaluate, I can put this in my calculator, 128 to the 1/4. So let's say 128 raised to the 1/4. That gives me that, okay? And then, what is that, 3.36. And then 8 to the 1/4. Oops, just kidding. 8 to the 1/4 power. And we get 1.68, okay, something like that. Now, here's the deal. You can also divide these two, which will become much nicer, all right? So if we divide these right away, because I notice if you look at my calculator, I put this in here, I notice that 128 divided by 8 is actually 16, right? So I would take this as a simplified exponential form, okay? And this would be it evaluated, or because these are both being raised to the 1/4 power, I can divide them. So you could also do 128 divided by 8 is 16 to the 1/4, and therefore this becomes 16 to the 1/4 is a much nicer answer. Oop, I need parentheses, right? If you have an older calculator, anytime you use a fractional exponent, it needs to be in parentheses, and that gives me a 2, okay? If you look, if I put this in my calculator, if you have a newer one, and you divide 3.36, 358, 5661 divided by 1.68, 179, 2831. Do you see how that's basically, there's a little rounding because we couldn't keep going with this, but if I divide those two crazy long decimals, what is that essentially? 2, okay? So it's a little tricky. When we take our quiz next week, I'm going to be asking you for this answer, okay? So I'm gonna want you to simplify these using rational exponents, okay? And then if I ask you to evaluate, it will end up being something much nicer than that, okay? All right, so this guy, no negative exponents. So what you have to do there is bring this to the top. So it's kind of the opposite of number 6. Now the negative exponent is in the denominator, so you're gonna bring that up. So it's gonna be 2 to the 1/2 power, okay? And then if I evaluate that, 2 to the 1/2 power is really the square root of 2, which is 1.4-ish about, okay? And that's my evaluated answer, okay. Don't worry about 17. Let's get rid of that one. Let's look at this guy. This one, we have 2 bases that are 2/3, right? And they are being multiplied. So if I multiply, that means I'm gonna add my exponent. So my base is 2/3. I'm gonna do 5/3 plus 1/3, right? Now, the denominators so I'm just focusing on this, gonna add that. 2/3 stays the same, base is always the same. So notice, base is the same, base is the same, base is the same, except for when I have multiple bases, okay? But most of the time, the base is gonna be the same. And then I add these 2 exponents, so it becomes 6/3. So this is 2/3. 6/3 is 2, so it's 2/3, right, in parentheses, just to keep that together, squared, okay? And then 2/3 squared means 2/3 times 2/3, so evaluated, this would be 4/9, okay? So that is evaluating using exponents, okay? Rational exponents. Again, rational exponents just mean fractional exponents. So remember your rules. Keep telling yourself, if you multiply, you add the exponents. If you divide, you subtract the exponents, okay? If there's an exponent in a power, you multiply. And then here, right, if you have multiple things within the parentheses, right? You're gonna raise both of them to that power, okay? And then there should never be negative exponents. Those are the big things, all right? So try the homework, all right? And I will talk to you guys soon.